Welcome back, everybody. Patrick here, moving on to the next question. So we are given this graph here of a polynomial function. And from this graph, there's three parts of the question. We have to state the x-intercepts, we have to state when the function is greater than 0, state when the function is less than 0. So let's start off with part A, state the x-intercepts. Well, pretty easy, already labeled for you on the graph, right? So -5, -3, and 2. So those are the answers. -5, -3, and 2. So at those x values, the y value is 0. The function has a value of 0. Part B, state when the function is greater than 0. So notice that the function is going to be greater than 0 all the way here. That's one of the intervals. So for all of the x values that are less than -5, so when x is less than -5, function is greater than 0, it's above the x-axis. And then also here, right? It's above the x-axis in this interval. So between x values -3 and 2. So when x is between -3 and 2. You can also show this in set notation. So you could say x is an element from -infinity to -5, right? Reading from left to right. It's not inclusive of the 5 because we're just asking when is the function greater than 0, not greater than or equal to 0. And then this one here, we can write as x is an element from -3 to 2. Right? So two intervals for part B. This interval here, then this interval here. What about when the function is less than 0? Well, it's going to be less than 0 in this interval. So for x values in between -5 and -3. So -5, -3, right? Two ways to do it, interval notation, set notation. And when the x values are greater than 2, notice the function is always going to be below that x-axis. It's always going to be negative. So when x is greater than 2, if we do it in set notation, it's from 2 to positive infinity, right? From an x value of 2 to positive infinity, the function is less than 0. And those are your answers to the question.